Hello and welcome back to part 2 of chapter 3. Um, I think it was really good timing because we stopped at the halfway point of the slides and very close to an hour. So I didn't want to overload your senses. And if you chose to play this right away for the second part, great. If you chose to take a break, that's always good. So let's get back into it. Well, what we went over last time, again, this may be right after you watch the first part, is that there are three types of claims that we make in research. Frequency claims are based on one measured variable. So the percentage of people who think that sports are important in the world. 4 out of 5 dentists recommend Colgate, etc., etc. I use that way too often. So I always wonder about that 1 out of 5 that doesn't. Anyways, frequency claims are one measured variable. Then we have association claims, which we know better as correlations. That was the last thing we talked about, which is two measured variables. Oftentimes they're called predictor and criterion variables. Does it matter which one's which? No, it does not. I use the example of crazy cat lady or crazy cat person. I don't want to get sexist on you. So you can measure the number of cats that a person has, and then you can measure their sanity on a questionnaire, standardized test type of thing. Or you can measure their sanity first and then measure their cats. In an association claim, to say that A and B have a relationship, it does not matter which one you measure first. So we use the terms predictor and criterion variables, as we'll see in the in-class sort of assignment. But that idea of which one you measure first, which is the predictor and which is the criterion, usually it just has to do with whichever one you want to measure first. So the predictor is usually considered the first one you measure, and the criterion is the second one you measure. So again, with crazy cat person, if you choose to do the number of cats that the person owns first, that is your predictor criterion, or predictor variable. Your criterion variable would then be their score on a sanity or insanity test, mental health test. If you choose to give them the test first, that's the predictor variable, and the criterion variable would be the number of cats they own. It doesn't matter if it's A and then B or B and then A. There is no preference, and it doesn't matter at all because we're not saying that one causes the other. But when we get to causal claims, those are the ones with one manipulated variable, which we call the IV or independent variable, and one measured variable, outcome variable, which we call the DV or dependent variable. Just to refresh your memory, in an experiment, we are trying to we are trying to show cause and effect with the IV and DV. In the example I gave you starting in chapter 1, I said that studying causes people to do better on an exam. Your score is dependent, this is the dependent variable, on which level of the independent variable you're in. So causal claims have one independent variable with at least 2 levels, a control group and an experimental group, and one manipulated dependent variable. In my example that I gave you, just to reiterate, the manipulated variable is the groups I put people in. There is a control group of 0 hours of studying outside the lectures, and there is 6 hours of studying based on that Carnegie unit in the syllabus. 0 versus 6, that's my manipulated variable. I can put half of the people in the control group, 0 hours of studying, and half the people in the experimental group, 6 hours of studying, and everybody takes the same exam, and I'm measuring the score they got on the exam. So my dependent or measured variable, my outcome variable, is going to be the score on your exam. And again, the reason we call it a dependent variable is based on my prediction, my hypothesis in the theory data cycle. What score you get is dependent on whether you studied 6 hours a week or whether you studied 0 hours a week. So that's the terminology for you. When we look at association claims, and we're just looking at a relationship, sometimes it's really easy, without them actually mentioning it, to spot whether it is a correlation, association claim, or whether it is a causal claim. In an association, we look at linked to, higher risk for. Obviously, these two are very close because association or correlation, right, is associated with or is correlated with, prefers, more or less likely to, may predict, is tied to, and goes with. Those are the verbs that we see a lot of times for correlations or association claims. When it comes to causal claims, we tend to see these types of verbs or this type of terminology. One causes the other. This affects the other, may curb or lessen, exacerbates, may make greater. Changes, lead to, makes, sometimes makes, hurts, promotes, reduces, prevents, distracts, fights, worsens, increases, decreases, trims, or adds to. These are showing some sort of actual causation, cause and effect. Studying, right? When we say that studying helps you to do better on an exam, what we're saying is A causes B. Studying causes you to do better on an exam. That is a causal claim. In an association claim, we would say there is a relationship between studying and getting better grades or better scores on an exam. See how the verbiage is different? I hope you do. This is a repeated slide, and I continuously forget to delete this one, so sorry about that. I never think about it until I'm actually lecturing. So, one of the things it's necessary for me to point out, and the book likes to point out, is that not all claims we read about in the press are actually based on research. And of course, that brings us back to chapters 1 and 2. Some claims are based on people's experience, right? No control group, and it has confounds. Some are based on a person's intuition, which is faulty by nature. Some are based on their authority, which can also be because of their experience or intuition, but they have a bigger platform that more people listen to. So, again, we want to know that these are legitimate claims. We want to know that we're not getting fake news or people are lying or they're making memes that are designed to make people think things are happening. We want to know that the research is real and that people aren't just relying on these incomplete pieces of evidence. So, you've now gone over the 3 claims. We know that a frequency claim has only one number and one measured variable. We know that association claims, aka correlations, have 2 measured variables called the predictor and criterion in either order. And we know that a causal claim is the only one of these claims that can actually assess causation or cause and effect. And in that case, we have one measured and one manipulated variable known as the DV and IV, or one manipulated and one measured variable known as the IV and DV. When we are looking at these studies, we want to know that the way that we have designed them to be good producers of research is valid. So there are 4 criteria, 4 validities that people look to make sure that their claims or their research is as valid as possible. Because if your claims are based on something else, intuition and things like that, and they're not actually valid, then it's a really poor design study. So here, even if you're not designing the study, you may understand some of these validities in order to be a good consumer of research. If you are conducting a study and you want to make sure your study has the highest validity, then you need to know these. Things as a good producer of research, because you need to make sure that these these issues are valid. So we are going to interrogate the 3 claims: frequency claims, association claims, and causal claims with the 4 validities. So I'll go over the 4 validities first, and then I will tell you which ones are important, less important, or not important at all for these claims. Here are the 4 types of validity. When you are constructing your study, your research, you want to know that whether you have 1 measured variable, 2 measured variables, or measured and manipulated variables, you need to, as we talked about at the beginning of this chapter, define them. We have our conceptual definitions, but to be credible for your studies, for your research, you need to know that you define them very specifically in a way that you can measure them and in a way that makes sense. So construct validity has to do with the way that you define your variables. And overall, it asks the question, did we measure what we intended to measure? So construct validity is concerned with how well the variables in a study are measured or manipulated depending on what you need. In a frequency claim, you have 1 measured variable. Did you measure that how you meant to measure it? So the extent to which your operational variables used in a study are a good approximation of the conceptual variable. If you are asking people how often they get aggressive, you need to know that your operational variable, right, operational definition of aggression as you're measuring it is a good measure of overall aggression. Are people saying aggression when they mean just mad? Are they saying aggression when they mean an actual act of becoming aggressive, right? That's construct validity. The overall question we ask, does this measure what we intended to measure? That's construct validity. External validity is asking the question of, does this study generalize to a larger population? When I went over the theory data cycle in chapter 1, one of the things that I said was scientists dig deeper. And that means that they don't just accept one good claim. If we found out that studying caused you to do better on an exam in our class based on our experiment, what it showed us was that it worked for you students in this class. That does not mean that what happened in our class may work for a different class, even another 92 class, which would have met next door or at the same school. So we need to know that it works for all research methods classes or for college classes or for classes in general. If you're going to make a claim that studying helps people to do better on exams or in classes, we need to know exactly what that means. So external validity is concerned with the extent to which the results generalize to some larger population. So the example given here is whether the results from this sample of children apply to all children in the U.S., school children, as well as other times, situations, whether the results based on this type of music may apply to other types of music, whether things that apply to 2020, well, maybe 2020 as a year isn't the best example, but current time, did they also apply to early 2000s or 1950s? Now, a lot of technological things did not apply, so that wouldn't have good external validity, but it depends on what it is that you're claiming. So external validity has to do with, can the results of this study be generalized to larger populations or other people? Statistical validity is probably what you'd guess it would be. Are the statistics that you used valid? Did you use the right effects? Did you use the right statistics? Did you have enough people per group? Something we call power. Did we minimize the amount of making a type 1 or a type 2 error, a false positive? There's been a lot of testing for COVID where people have been told they were positive and then found out that the test was wrong. That's what we call a false positive. Or if they said that they were negative when they were indeed positive, that would be a false negative. We don't normally see that, or we would call that a miss or a type 2 error. Hopefully you remember this from statistics when you took it, either last semester or maybe a little farther off in the distance. So statistical validity addresses the strength of an effect and its statistical significance. the probability that the results could have been attained by chance. You may remember that we have a 95% chance when we set our statistics, alpha equals 0.05, if you remember that. What that means is we are showing that the chances of the statistics we got, or the numbers that we got, were of them being mistake or error, is less than 5%. And that's pretty good. So this also addresses type 1 or type 2 error. Did we have enough people per group? Did we have enough groups? Did we run the right statistics? Wow, that sounded really weird coming out of my mouth. Statistics. If you are doing an association claim or correlation, did you use an R value? If you're comparing two groups, did you use a t-test? If none of this sounds familiar, we'll go over it more as the semester goes on. That is statistical validity. The last one, and this is the one I prefaced last lecture, that only accounts for a causal claim, is internal validity. And what internal validity is asking that if you're saying that A causes B, this is the relationship that A actually causes B and not something else. So one of the things I talked about as a potential pitfall in that studying example is, what if one of the groups or some of the people were exposed to caffeine, which may help their concentration and help them remember better? What if that contributed to their overall score because they were able to remember better based on caffeine? So internal validity says, if you're saying that A causes B, what you're really asking is A and only A causes B and not C, D, or E. So if we were to go back to that studying example, which I like to use because let's keep it consistent, we are asking the degree that studying and only studying causes you to do better on an exam, and not caffeine, not what you ate, not how many hours of sleep you got. We want to know the relationship between, or the cause of A and B. So we would hold all those other things constant. As I pointed out in chapter 1, one of the things we could do, if we had the time and money and resources, is to make sure that nobody drinks caffeine or ingests, because you can get it in pill form and stuff like that. So when I give you guys the test, the only difference I want between the groups that I can, to the best of my ability, control for, the only difference I want everybody to get the same amount of sleep. I want everybody to get the same, eat the same meal. Maybe we do a mid-morning test and everybody gets a nice healthy bowl of oatmeal. And that nobody has caffeine. So the only difference I want between the groups, same amount of time, same lectures they go over. The only difference I want between the groups is the manipulated variable. That after you watch this video and go through the lecture, the control group, no studying whatsoever. Don't even pick up the book. Don't tempt yourself. And the other group, 6 hours of studying, as close to 6 hours on the dot as possible. That way, we can say with relative certainty that people got a higher score because they studied, not because they had caffeine, slept more, or ate something different. We want to know that A and only A causes B, not C, D, E, and F. Caffeine, sleep, what you ate, things like that. So that's what internal validity is. Internal validity is making sure that A and only A causes B and not something else. So to review, construct validity is the quality of the measures and manipulations. Did you define these things the way that they should be? Are we measuring what we are intending to measure? Statistical validity, are our statistical conclusions appropriate? Are they reasonable? Did we do the right statistical measure? Did we have enough power or people, right? Effect size, sample size, all of that stuff. We'll get to that a little later as a review. Did we make a type 1 or type 2 error? That's statistical validity. So construct validity is going to apply to all three of the claims. Statistical validity is going to be applicable to all three of the claims. Even though you only have one measured variable, you need to make sure you measured it correctly. You need to make sure you defined it correctly. You need to make sure the number you have is within the appropriate confines. External validity, down here, we're going to go clockwise. External validity, to whom, what, or where can we generalize? In a frequency claim, this is the priority. If you're saying that blah, blah, blah percent of college students experience this, you want to know that if you're talking about college students in the US, that you can generalize that to all the college students as much as possible. If you make a claim that, blah, blah, blah percent of teen pregnancies end in this, you want to make sure you can generalize that as best as possible to all. A lot of times we look at polls for, now that, an election is around the corner, we can look at the polls and what they say for who you're going to vote for this office, president, of course, and other things. You want to know when you make a claim like this that you are representing all of this state or all of the country based on this claim. So frequency claims, external validity is of the highest importance. You still need construct validity. You still need statistical validity. Internal validity does not apply to a causal claim. I'm sorry, only applies to a causal claim. Does not apply to a frequency claim. When we look at an association claim, construct validity means did you measure, right? Did you define your two measured variables in a way that makes sense? Did you measure what you intended to measure? The number of cats somebody owns? Pretty easy. Count the number of cats they own. Does this mean cats that are alive, cats that are dead, right? Well, you need to be very specific about that. Statistical validity says that you are using the right measurements, that you didn't make a type 1 or type 2 error, that the numbers that you got were actually the numbers with 95% or more confidence. So construct validity and statistical validity are both super important for an association claim or correlation. External validity, to whom does this apply to, really probably depends on what you're asking. If you're just looking at crazy cat person and you're not looking to generalize that to all people who own lots of cats, well, then you don't need external validity. But if you are trying to make a claim that all people who have multiple cats are somewhat insane, right? Then your external validity would be more important. So in an association claim, external validity may or may not be important. The last thing we're going to talk about is internal validity. Remember, internal validity says if we're looking at A and B, that A causes B, we're looking for no alternative explanations for the outcome. So if you are looking to test a drug, that was one of the other examples I gave you. If you're looking to test a drug, then you're going to ask the question, you're going to give them at least two possible scenarios. Your manipulated variable would be a placebo that has zero amount of the drug in it. And you have the actual drug itself. Let's say it's 50 milligrams of your medication. So you have two groups, 0 and 50. And what you're looking for is to see if somebody's, let's say it's a new antidepressant, and you give them a depression test. And so the higher the score, the more depressed a person is. So what you're looking for is that taking the antidepressant makes their scores go down when you give them the test again. Internal validity says it's the drug and only the drug that causes the reduction in their depression or in their score. So we don't want to give them the drug and have them go to therapy, because it could be the therapy that makes their score go down or the combination of the two. We want to know that it's the drug and only the drug. So what other things could be interpreted? Maybe somebody's depression could be, as we talked about in chapter 1, that aerobic exercise may be able to relieve some minor to moderate depression. So we want to make sure either nobody's exercising while during this drug trial, or everybody's exercising. The only difference we want between the groups is what we manipulate. So if we're doing an antidepressant drug, nobody gets therapy while they're doing this. Nobody is exercising any different. And if we could, everybody's eating the same things, right? Because, maybe gaining weight could cause people to be more depressed because they're not happy with themselves. So if we can get people to follow the same diet, to not exercise, or everybody exercise the same amount, for nobody to go to therapy during this time, we want to know that A and only A causes B. And for this, the only one that internal validity applies to is a causal claim. And in fact, because we're trying to say that A and only A causes B, internal validity is the absolute most important factor to a causal claim. Construct validity applies to a causal claim because you need to know that your measures and manipulations, manipulated variable and measured variable, are both as accurate as possible. You need to know that your statistics are as accurate as possible. Internal validity is the most important. And what about external validity? Well, again, kind of like an association claim, it depends. We talked about in chapter 1 basic research, sort of the conceptual, just seeing if a theory is correct. Does studying actually help you to do better on an exam? When you first run a study, external validity is not important at all, really, because if you can't show that the studying actually works, then there's no reason to generalize it to other people. So when you're first running a study, external validity is either very low on the scale or not really important at all. However, once our 92 class shows those that study do better on the exam, when we go into replication with other people and other times, then we would say external validity is important because we want to know that it's not just a theory for our class, but it's a theory that works for college and maybe high schools and all students, all college students, or all students in general in classes. So, moving on. In frequency claims, we are asking the question of construct validity. How well was the variable measured? When you say dentists recommend Colgate, again, because I seem to not be able to get away from that example, I just like it. How did they define liking? How did they define, was it taste? Was it kept cavities away? Was it all of that? Statistical validity, how large is the margin of error? We want to know that. But the essential one is external validity. When you're saying that they recommend Colgate for your teeth, they're looking for everybody that has teeth that should brush them, right? So can we generalize from the sample to the population? When we talk about what the polls say for presidential elections, we're looking for everybody in that state or everybody in that county or everybody in that country, and how it can generalize to the prediction of who's going to win. So external validity, again, is essential in a frequency claim, and you need construct and statistical validity. Internal validity need not apply. There is only one measured variable. We're not looking for any causation, so there's no place for internal validity in a frequency claim. Looking at association claims, construct validity is important, very important. How well was each variable measured? Was it accurate? Did we measure what we intended to measure? You need that. Statistical validity. How strong is the association? If you're looking at an R value, is it what we call statistically significant? Does that show a significant relationship between two things? Now remember, looking at the association, anything around 0 is going to be no association. Anything that's towards 1 or -1, depending on if it's a positive or negative association, the stronger it is, the more possible we can actually predict that one may cause the other. So statistical validity is very important. External validity, to whom or what can we generalize this association? It may not be important at all. If you're trying to make the association between vaccinations and autism, then you need external validity for that, because you're saying that it does or it does not cause autism, and that should be externally valid, right? If you're just looking at two things like the number of pets that people own and the size of their house, then maybe that's not such a big deal for generalizing to the public or the population at large. So construct and statistical validity, very important. External validity really depends on what you're trying to say or who this relationship is important to. Internal validity, once again, correlation does not imply, you guessed it, causation. So in that sense, no internal validity necessary in an association claim. When we get to statistical validity, we're looking at the strength of the relationship, the significance of the relationship. Is it positive? Is it negative? Is it closer to 1 or -1? The closer it is, the more we can possibly look at it as a causal claim eventually. We also want to make sure that we are not getting a false positive and not getting a false negative. So type 1 or type 2 error. Again, statistical validity, very important in association claim to be correct. Finally, we get to causal claims. In causal claims, do we need construct validity? Absolutely. So construct validity is important in all three claims. How well was the independent variable manipulated? 0 versus 6 hours of studying, pretty good. If it was 0 versus 2 hours of studying a week, is that really enough to make a difference? No, but 0 versus 6 seems to be a pretty good measure. How well was the dependent variable measured? The score you got on your exam seems to be a good indicator of the information you knew from studying because you got it right on the exam. So construct validity is very important. Statistical validity, if we're trying to say that one thing causes another, we need to see the difference. So is there a difference? Is it big enough? Is it statistically significant? Did we make a type 1 or type 2 error? Right? Did we say that somebody had a positive COVID test when it was actually negative? We don't want that. That's a type 1 error. Did we say they didn't have COVID when they actually did? That's a type 2 error. So like an association claim, it's monumentally important. External validity, to whom or what can we generalize this? Rarely prioritized in an experiment, at least the first time that you're doing it. If you are replicating an experiment that you've done, right? We found in our class that that those that studied got a better grade. Let's try it on another Psych 92 class. Let's try it at West LA College. Let's go over to New York and try it in a middle school. That's when external validity is important. But when you're first doing it, external validity is rarely prioritized. But this is the only claim where internal validity is here. When you're saying that A causes B, that studying causes you to do better on an exam, that this new antidepressant causes you to be less depressed, we need to know that it's A and only A that causes B, not whether or not you had therapy at the same time, if your diet was poor, if you exercised while you were taking this drug. We only want the difference between the two groups to be whether or not you took the drug, whether or not you studied. We don't want it to be because of what you ate, how much you slept, whether or not you had caffeine. The only difference we want between the groups is whether or not you studied. One group, 0 hours. One group, 6 hours. Other than that, they eat the same thing for breakfast. They get the same amount of sleep if they can, if we can control for that, and nobody gets caffeine. This is internal validity. If we're saying that studying causes you to do better on an exam, what internal validity is trying to help us with is that studying and only studying helps you to do better on that exam. The antidepressant drug and only the antidepressant drug helps you to lower your level of depression. changes your score on that test and makes you feel a little better. And that's the priority of a causal claim. So again, just looking at this overall as we wind down this chapter, and you're probably thinking, thank goodness, but it's an important chapter. Construct validity in a frequency claim. The frequency claim says nearly 60% of teens text while driving. How well did the researcher measure the variable in question of texting while driving? Did they measure what they intended to measure? In an association claim, shy people are better at reading facial expressions. There is a positive association between your level of shyness and how well you can read facial expressions. How well has the researcher measured each of these? Shyness, was the shyness test really accurate in predicting shyness? Was their ability to read facial expressions as we had asked for? Did you measure what you intended to measure? For a causal claim, music lessons enhance IQ. Those that took lessons would have a higher increase in IQ than those that didn't take music lessons over 6 months or something. How well has the researcher manipulated or measured the variables? Music lessons versus no music lessons should be pretty good. An IQ test is standardized, so hopefully the change in IQ should be pretty good as a measured variable. Statistical validity, again, important in all three. What is the margin of error for the estimate? When asking about a frequency claim of 60%. Is that 60% a valid number that you got from the statistics? Looking at shy people and facial expressions, you measure the shyness, you measure the ability to read facial expressions. What's the effect size here? How strong is the association? Is it statistically significant? If the study finds a relationship, what's the probability that it was a false positive or type 1 error? What's the possibility if there is no relationship? What is the probability that the researcher is actually missing a relationship that is there? Type 2 error. So you have statistical validity, which is important in all three. So there's the association claim. In a causal claim, what's the effect size? Is there a difference between groups? Is the score between those that studied and those that didn't study different enough to say that one is higher than the other, or that they're statistically significant or significantly different? For music lessons, is the IQ increase or the IQ change significant enough to say that those that took music lessons had a significantly bigger increase in IQ? Is there a difference between groups? How large is it? Is it statistically significant? And again, did we make a type 1 or type 2 error? Did we say there was an increase in IQ when there really wasn't? Did we say there was no increase in IQ when clearly there was and we just didn't capture it? Internal validity here is not necessary for a frequency claim, only one variable and no causation. So you're not assessing or asserting causality. So internal validity, not relevant at all in a frequency claim. Association claim, you're just looking for a relationship. You're not saying causation. So again, correlation does not imply causation. So here, once again, internal validity, no place in an association claim or a correlation. Only in a causal claim, and it is the most important in a causal claim. Was the study an experiment? Does it achieve three things that you need for a causal claim? Temporal precedence. What it means is that if you're saying A causes B, A has to come before B. So if you remember when I talked about this, either at the beginning of this lecture or at the first part, I said that if you're measuring, for crazy cat person, if you're measuring the number of cats, or you're measuring and you're measuring their sanity on some sort of scale, it doesn't matter which one you measure first. You can measure the number of cats first. You can measure their sanity or insanity level first. It doesn't matter B or A. In a causal claim, if you're saying A causes B, then A has to come before B. That's temporal precedence. So if you're saying studying causes you to do better on an exam, you have to give the studying or not studying before you give the exam. If you give them the exam and then have them study, it makes absolutely no sense. So that's what we mean here when I say temporal precedence. Also, does it control for alternative explanations by randomly assigning? We also don't want, if we were in class and the first people that came in the door all went over to the right side of the room, and the people that came in late, kind of unprepared, maybe didn't have a pen or pencil and didn't have their laptop or their notes out, were sitting on the left side of the classroom. That's a problem if I just separate you like that, because how do I know that the people on the right were better at taking notes for the lecture and the people on the left were not really good at it and not really going to pay attention? Then we already have a difference before I give the exam. So randomly assigning to groups, meaning you have the ability to be randomly assigned. So you don't know which group you're going to be in. I randomly put you in one group or the other. And does the study avoid other internal validity threats? We're going to go over those later. But basically, the biggest things we want to do is control for things so that the only difference between groups is whether or not you studied. Everybody sleeps the same amount. Everybody eats the same breakfast. Everybody gets 0 caffeine. The only difference between the groups was whether or not you studied 0 hours or 6 hours. That's it. And this is the most important validity in a causal claim. For external validity, to what population settings and times can we generalize this? How representative the sample? For a frequency claim, external validity is the most important. In an association claim, it's both construct and statistical. Internal doesn't apply. External, it depends on what you're measuring. So to what populations can we generalize crazy cat person or, whatever association you're trying to make, height and weight of children. For a causal claim, again, especially the first time you're running it, it's usually low importance, if any. When you're doing a replication, maybe, and you're seeing if it works, once it worked in our class, seeing if it works somewhere else, then external validity is a lot more important, right? Hopefully that came across, because I think I've repeated myself like 1,000 times. So, hopefully. And it can be 1,000 more if you watch this video twice. So for causation, I talked about having some criteria to make sure that it measures up to a causal claim. Covariance is actually satisfied by more than one claim. Association claims are meant to see if there's a relationship between A and B. So all covariance says is that there has to be a relationship. For one to cause the other, you have to have a relationship. There has to be a relationship between studying and your exam scores. You could find this out in an association claim. So of the 3 criterion, the first one will be good for an association claim and for a causal claim. It just means that A and B have some relationship with each other. You have to have a relationship with each other for one to cause the other. So covariance says as A changes, B changes. Higher levels of A may go with higher levels of B, low with A, low with B, or vice versa, depending on what it is. But there has to be some sort of relationship. In an association claim, that's all you're looking for. So covariance works for both causal claims and association claims. But that's it for the 2. Temporal precedence, as I just told you, A must come first in time before B. For crazy cat person, it doesn't matter which one you measure first. You can measure A or you can measure B. We use the terms predictor and criterion variable not in the same way that we use independent and dependent variable. In an association claim, it doesn't matter which one's A or which one's B. You can measure any of them in any order. In a causal claim, though, A has to come before B. As I said, you can't give an exam and measure something, an exam score, before you give them the studying or not studying. The manipulation has to come before the measurement. You have to give them drug or placebo before you measure their decrease or, change in amount of depression. You have to give them studying or not studying before you give them the exam. A has to come before B. This is temporal precedence. And of course, this idea of internal validity means that there is no alternative explanation, so you have to control for all those other things. Meaning that the only difference you want between groups is whether or not they actually studied and nothing else. We want to make sure that nobody gets caffeine. We want to make sure that everybody gets the same breakfast if we can before they take the exam, so that there's no difference in not eating versus eating, or just eating a bowl of sugar as opposed to eating something healthy like oatmeal. For the drug versus no drug, an antidepressant, we don't want it to be explained by having cognitive therapy or by exercising more or by having a different diet. So you would make sure that the only difference between groups is whether or not they got the drug. Same diet, no psychotherapy, and maybe no exercise during that time, or no exercise, other than their normal stuff, whatever. So that's what internal validity says, that A and only A causes B, and it's not C, D, E, F, or G. These three criteria are met, then you have a good causal claim and you have good internal validity, which is the priority. So experiments are the only ones that can support causal claims. How do we look at causal claims? We run experiments. We have a control group and an experimental group at very minimum. That's the manipulated variable, or the IV, the independent variable. And we have a measured variable, or the DV, dependent variable, outcome variable, what number we're getting from this. So looking at that as an easy way of looking at it, or we can look at this figure. What do we see here? So in an experiment, we have an independent variable, a dependent variable, and we do random assignment, because if we just assign people sitting on one side of the room versus the other, or whoever comes in first is going to be in one group, there may be differences just because of the group that they're in before we even give manipulations. You may have people that have played an instrument before that are already in one group, and people that have never played an instrument before that are in another group, and you give the people that have played before the music group. That's not going to do you any good. So we randomly assign people that come in. You randomly say, this person you go on the right, this person you go on the left, that person you go on the right, that person you go on the left. Okay, the group on the left is no music, the control group. The group on the right is music. So here, instead of two groups, we have four. Looking at the bottom, the x-axis is going to be your manipulated groups. That's always the manipulated variable on the x-axis. The measured variable is the score you're looking for on the y-axis. So here we have two different types of music lessons and two different types of no lessons, or no music lessons. Looking at this, how did they operationally define music? Well, they used four groups. Here is a group that took keyboard lessons, so learned how to play a piano or keyboard. Here, in this second group, are people that learned to sing. So their instrument, their music, was their voice. They were in choir, maybe, or singing in a musical. Here, people got drama lessons, so they were learning to act, but without music. So this would just be straight acting. No music involved, not playing an instrument, not using your voice, just acting. Or people that got no lessons at all. So you have two in the music group and two in the non-music group, or the control group. And here we see what they're measuring after, let's just say, this is 6-year-olds who completed the study. Let's just say that it was an after-school program, which usually lasts about 4 months, right? I know my son was in after-school programs September, October, November, and through December. So we'll call it 4 months. And here is the change in IQ, the increase in IQ. That's going to be your y-axis. That's your number that we're looking at. So those that took keyboard lessons for music increased about 7 IQ points in the 4 months. As a 6-year-old, those who took voice lessons, also about 7, maybe a little bit higher than 7. So this is about the same. They increased about 7 full IQ points. Those that took drama, maybe about 5 IQ points. And those that took no lessons at all, about 4.5 to 5 IQ points. So all the kids increased in IQ as you're learning things in school, but those that took music seem to increase more than those that didn't. That's where experiments can cause that. So we wanted to make sure that everything else they're doing in school is the same. So all the kids, all the 6-year-olds are taking the same classes or have the same subjects, maybe even the same teacher from the same class. The only difference between these groups is these two are either using a musical instrument or their voice as a music lesson, and these two groups have no music in what they do. This one is acting as an after-school program maybe, and this one is just going home and not doing anything. So that's where we can support causal claims by using experiments that actually manipulate a variable into at least two groups, or four in this case, measure one variable here, and randomly assign into these four groups or two groups. So you have to make sure when there's causal claims that you're not doing this by mistake. This is where being a good consumer of research really comes in. When we ask questions, we are looking to see if there's actually causation or if there are no other alternative explanations. So, this would be perfect if you guys were in class. When I ask the question, do family meals really curb eating disorders? Am I going to, is it just so easy to say, well, one group we can put that has eating disorders and doesn't eat with family meals, and one group that has eating disorders that eats with their family? Well, do family meals really curb eating disorders? The problem is what other explanations could we have for curbing eating disorders? Is it the presence of their family that causes them to stop eating disorders? They could be taking medications to stop eating disorders. If they're anorexic, maybe they're taking an antidepressant, which seems to work. If you took Psych 2 with me, you would know that, based on chapter 6 in that book. Or could it be something else? Could it be friends that talk to them? Could it be seeking professional help, getting therapy? So this is not good as a causal claim. There may be a relationship between family meals and eating disorders going away, but that doesn't mean that one causes the other, and there could be plenty of other explanations. Just like this next one over here. Do early language skills reduce preschool tantrums? A lot of times we hear about children throwing tantrums because they're not verbal yet, and the parents can't understand what they want, if they want food, if they want a toy, if they want attention. And so they'll throw tantrums seemingly because they can't verbalize it well enough to let the people know what they want. But the question is, do early language skills reduce preschool tantrums? Sure, you could run an experiment and say, here's kids that can verbalize at preschool age, and here's kids that cannot verbalize at preschool age, and then we can look at the number of tantrums in a given semester or in a given week. But asking this question as a causal claim also means that you rule out alternative explanations. Well, if a child doesn't get their way at home, they don't get the toy that they want to bring to school. They don't, it could have to do with nap time and not wanting to nap. These are all different reasons for throwing tantrums other than they can or can't verbalize something. So again, it would be a mistake for this causal claim because there could be other explanations for tantrums. My son was very, very verbal. He started talking at 7 months of age. When he was upset at preschool, it might have been he got the wrong thing in his lunch. He didn't want, tuna. He wanted peanut butter and jelly, or he just wanted cookies for lunch. It could be because he had an accident at school and needed to change and felt embarrassed. That could be a tantrum. So it's too many explanations. So it's a mistake to ask these questions unless you control for all these other things. So other validities to interrogate in causal claims, all three, as I said, construct validity for all three, external validity to a degree for all three. Sometimes it's important, sometimes not at all. Statistical validity is definitely important in all three. So when we're looking at the right way to go about this to be a good producer of research, or if you're just looking at what the study says and trying to be a good consumer of research, there are proper ways to address things and say things as opposed to others. So instead of saying the question is the study valid? Well, now we know that there's 4 different validities. So we can't just ask, is a study valid? 2 of the 3 claims don't even care about internal validity, so that wouldn't be part of it. You need to be more specific when you're talking about it. So you can ask something like, how's the construct validity? Did it measure what it intended to measure? Is external validity relevant here? For a frequency claim, always. For the other 2, not necessarily at all. Or to say that this is or is not a valid study is not a good way to talk about it. You need to be more specific. Can this study support a causal claim? Are we looking at causation? A causes B. Does it not matter? Right? So there are proper ways to phrase things and say things instead of just a general blanket study. This question is valid. Is it valid overall? Is it not valid? We need to know what type of validity and what type of study or claim that we're making. So looking at, again, not just saying that study is just not valid. Which validity is appropriate to interrogate for every study? Again, this is where I'd ask you at the end of class. The answer, of course, being construct validity and statistical validity, always relevant in every claim, all 3 claims. Which validities are not always relevant for a study? Well, for association claims and for causal claims, the answer is external validity, although it is absolutely important for frequency claims. For frequency and association claims, I know I'm repeating myself over and over, the answer is internal validity because it doesn't even apply to them. In a causal claim, however, internal validity is the most important. Why can't researchers achieve all 4 validities in a single study? 2 of the 3 internal doesn't even apply. And in causal claims, external validity is usually the lowest of importance. So in a causal claim, it is possible to achieve all 4 types of validity, but most of the time, external validity doesn't matter. And if we're really concentrating on internal validity, we can sacrifice. So which 2 validities are most often in a trade-off? I would say internal and external in that case for a causal claim. Which validity is most under the researcher's control? Absolutely, that one is internal validity because you're manipulating and controlling for those variables. If you want to say that studying and only studying causes you to do better on an exam, then as the researcher, you must control for nobody getting caffeine, everybody sleeping the same amount of time, everybody eating the same meal beforehand. Of course, allergies may play a part in that, but overall, right? That's the one that's most under the researcher's control because those are the variables you can control for in internal validity. Otherwise, it's hard to say that it wasn't caffeine that caused people to do better on a test as opposed to studying, or both. So that's how we do that. Thank you guys for sticking around for this. I'm sure you're glad, as I am, that I split it up into 2 lectures. Now we are 3/4 of the way through the first module and on our way to the first exam. So thanks for sticking with me. And as always, I'll talk to you. I will talk to you soon as this lets me. Thank you. Talk to you later.